Acid halide reacts with water to yield carboxylic acid. So if I have acid halide and this is treated with water, we will have a carboxylic acid. This reaction is a nucleophilic acyl substitution reaction. So this reaction is nucleophilic acyl substitution. So basically we have replaced this X, that is halogen, with an OH group. So this reaction is a substitution because halogen is substituted by OH group. Since this substitution is happening on acyl carbon, that's why this is acyl substitution. So substitution is taking place on acyl carbon. Let us discuss mechanism of this reaction. So we have acid halide. This reacts with water and this gives acid. Let us take a special case of acid chloride. So we have acid chloride and this reacts with water. This time water will act as a nucleophile and this will attack on carbonylic carbon. So this step is nucleophilic attack, or you can say nucleophilic addition of H2O, and this bond opens. So we will have this molecule. Oxygen will have a positive formal charge and this oxygen will have a negative formal charge. This intermediate is called tetrahedral intermediate. So this is tetrahedral intermediate. Basically it can be deprotonated. So we have this intermediate and this can lose H plus so that it can have OH group. So this is again tetrahedral intermediate after deprotonation. And this step is simply deprotonation. So this step is deprotonation. Now in the next step, this negative charge can expel this Cl minus and finally we will have acid plus Cl minus. Now in this step we have released 1 mole of H plus. So this H plus and this Cl minus can combine. So finally we will have RCOOH and HCl as the product. If I want this reaction to go in the forward direction, we can destroy HCl, that is, we can neutralize HCl. So to make this reaction in the forward direction, we have to neutralize HCl, and this can be generally done by adding a small amount of NaOH or pyridine. So neutralization of HCl is generally done by adding NaOH or pyridine. So pyridine is a base. So in this lecture we discussed about hydrolysis of acid halide. Acid halide can be easily hydrolyzed in the presence of water. Like other derivatives requires catalyst, acid halide does not require any catalyst. It can be simply hydrolyzed in the presence of water. And the reaction is nucleophilic attack by H2O. It gives tetrahedral intermediate, and then halogen is a good leaving group. So in the next step we have to expel the halogen. So in this step, halogen, in this case chloride, is a good leaving group. For another acid derivatives, this group is not a good leaving group. For example, if we have amide, we will have this tetrahedral intermediate, and this time we will have NH2 is a leaving group. So this is not a good leaving group. In case of ester, we will have OR minus is the leaving group. This is also not as good as X minus. So this is not as good as X minus, that is halogen. Thus by hydrolysis of acid halide is fastest among all acid derivative.